venture capital went crazy, and I filled up KC7, and then I started to fill up KC8.
Just know your conversation's probably going to be live streaming in a second.
Oh, I spent millions of dollars on servers that people don't use. So, yeah. Everything you're talking about.
Was that pre-shift left? Was it
right about the time they said shift left is about the time I
moved? Oh yeah. That's good. That's what it sounded like.
Yeah. I tried so in ETS, Jewish Religion guy, I was on the leadership team. Okay. And I just wanted the hell out of continuous.
It might work.
Everything else is working. We're already live streaming.
Oh yeah.
It all works.
Oh,
of course.
It took me half an hour to set up.
Full on board for it. Because man, I spent
20 years to be an overnight.
Too many years of my life stuck in midnight conversions. Doing
amazing.
Long
it works. It's magic.
This Mevo here is like on software. It just
yes. Things are never magic.
Your mom is calling.
Okay.
It didn't work. How did it not work?
It's probably because my mom called. How good are you?
Move right?
Yeah, I'm in infrastructure now.
You're in what?
Infrastructure.
Oh, are you?
Yeah.
Okay.
Still in CTS. But
still in that, yeah.
Yep.
I made a move too, so I don't work too much.
Yeah.
But a lot of people moved. I mean, it seemed like everyone kind of left after
yes. Couldn't take it anymore.
Play with it.
Yeah, Stacy was.
We have to connect to YouTube. Or just record. I think there's a whole bunch of texts to do.
Your users will see what's in this rectangle.
Yeah, it's the Android app. I don't think is fully baked. So Dustin and I, neither one of us can connect to it now.
Hey, hello, sir.
Good. How are you doing?
Good. Well, that was one of the things I was like, we could buy an Android tablet, but it only works with iPhone.
Where do you want
No,
me to?
it works with Android now.
That's not the way it was last year. Last year, it didn't do
Where do you
YouTube, and it only worked with iPhone.
Yeah, that's why we dismissed it, but now it works with Android, supposedly, although not great.
Where do you want me to record to?
It's for YouTube, I think, or we could do somewhere else. And then
I'm already
I don't have it.
streaming to the channel identification.
can we stream to a different. Stream twice?
No.
You only do it once per account.
We want to just stream to somebody else's account. Pick it
Test.
up later.
Yeah.
Someone has to set up live YouTube, which is not negligible. It takes about 10-15 minutes.
Really?
What about Periscope? Does anybody have a Periscope account?
I do. I don't know what it is.
What?
Yeah, it's the
So, you're restarting that company? Was anybody watching?
Yeah. I've been there for about a month now.
Okay.
Yeah, I get a whole bunch of people. A whole bunch of people here for that. Yeah. Okay. Yeah, it's great. It's a great culture. Everybody seems to get it, you know?
It's less politics?
Oh, yeah, substantially less. I mean, their idea of politics is like just nothing. I mean, that's a joke compared to what I've dealt with in the past. Okay. But yeah, it's pretty impressive. I was surprised just how good it was. I guess I will log into my Periscope account. It's probably
Well, they should be sending
Where are you at now? You still in the center?
So are you still an IP then?
No,
Are you
yeah.
still?
I still report to Brian Wallace.
Yeah.
Do you ever work with Linda Salzer at all?
Mm-hmm.
So she has taken over the leadership responsibilities for.
So I thought we
now. We were kind of co-sharing.
Yeah.
I'm getting more into technical details of that. So I decided to take a break from the leadership part of it. And just,
The churn.
so I'm enjoying it.
Yes.
Having my focus on my project, and that's it. No other problems. So,
Yes.
but yeah, so I've been over the past year transitioning out of the Jira stuff.
Yeah.
I thought it was Ryan. Yeah.
Completely done.
Yeah, I've made a couple
He's
moves
out there
since I
getting
moved off the Remedy team, but yeah, if you don't move far enough away, then still.
Yeah, that's a problem too.
No, you're good. Yeah, you still get hit up for stuff. I still get hit up for like Remedy questions to this day.
Sure.
And I'm like,
Whoa. Check. Yes. It works.
you are in it. Yes, well, the laptop is kind of covering your head north.
Hello and welcome to the December, I gotta write this one, December DevOps meetup. We're going to get started here shortly. We have a schedule tonight where we're going to do What is DevOps with Ryan McMahon. We're going to hand it over to Dave to do the news. And then we have Randy who's going to talk about microservices, which I assume is why we have a much bigger group than normal here. So that's super awesome. So, let's see, things that we have coming up in January. We do not have a place or a theme for the meetup. So if anyone wants to contribute, either a place or a theme or a sponsor, let us know, and we'll try to get that figured out. We'll also probably do a survey at the end of the year, like we did last year, to get an idea of what you guys like and what you would like to see going forward. More talks like this, more open spaces, whatever that may be. We also have DevOps Days Des Moines coming up. I believe it's in April. It's going to be their first one, so if you've been to DevOps Days Kansas City, I think this will be a very similar format, except for 3 hours away. I think that's going to be like the only difference. Probably different people, I don't know, more people. But we should get groups together to go up to that. I believe their CFP is open, and it is open until January 15th, is what I heard. Those are the announcements I have. Now is where I turn it over to you. Does anybody in the room have announcements? Things that we usually announce are other meetups that we should be attending, upcoming conferences. There's an upcoming conferences room in the Slack, so if you're not already in the Slack, you should jump in the Slack. We have very spirited discussions sometimes, and silly discussions other times. And also job openings, or if you're looking for a job. I'm starting to see hands. Okay. We're at the JavaScript Kansas City meetup, December 12th. That's next week on Wednesday? Tuesday. Tuesday next week, and where are they at? C2FO? Yep, that's where we had our last meetup. It's an awesome place. Any other things coming up? Anybody looking for jobs? Anybody have jobs that looking good for people? Yeah. Oh, here we go.
Yeah, I have a open position at American Century Investments on the red team for the
American Century? Yep. And have you put that in the job opportunities? Oh, yeah, excellent.
Yeah, I got one. So I'm at the NAIC. It's the National Association of Insurance Commissioners. And so we help the insurance commissioners, the insurance regulators at all the different states and territories help better regulate the industry. We also work with industry companies to help them kind of get their data into the system. So I'm looking for a data engineer, someone who has some programming experience and also likes to work with data and data models for the enterprise architecture team. I'm also looking for someone who has Tableau experience. I'm also looking for someone who will be a good cloud enterprise architect. So mostly focused on cloud for now, but I like journalists. So DevOps, cloud type enterprise architect. And that last one is not yet officially available. So once it's finally available, we're just working through the process. Feel free to contact me on Slack if ready. The other ones have been posted in job postings, and I'll post them again tonight.
Excellent. Do you have any other announcements? This is that part where I just always awkwardly go out. Nobody? All right, I want to have a huge thanks to our sponsor, Cerner, for the food and the venue. So go ahead, applause. And by show of hands, who is the first meetup for you? A large number of the room. Show of hands, applause for that. So since it's your first meetup, and you want to know what is DevOps, that's what we're going to kick things off with. So we have Ryan McNair, who's going to run through what is DevOps.
One version.
Ryan's version.
Do it live in production.
The DevOps adapted.
Oh. Put it on Google Drive.
What is DevOps? All right, cool. Sweet. Okay. My name is Ryan McNair. I really enjoyed this meetup, and it's awesome to see a lot of new faces here. This is a lot larger audience than I thought it would be possible. I don't do a lot of presentations. We share what is DevOps at the beginning of each meetup because there's a lot of definitions, because DevOps is used in a lot of different ways by a lot of different companies. And I haven't yet heard my definition, or something close to it. So I wanted to get on the list and share it. A little bit about myself, my background. I've done some development, I've done some operations work, I've done some project management, and right now I'm doing some product management. So I have a certain perspective of this that looks more end-to-end of the development flow, and I want to talk about DevOps in terms of the value stream, the business value stream. So I made some diagrams here. Very simple software development value stream. I put 5 things on here, and at the end of the value stream there is a CD. There's a distribution of software. And so if you think about companies that were organized to deliver a distribution, there was a CD or a floppy disk or whatever, but it ended the value stream like that, and the customer would purchase that. That's what they were selling, and that's what they were buying. And so you organize everything inside of your company around delivering that. Hopefully everyone can identify with this a little bit. So we can add operations into this now. We're no longer delivering that product as a distribution of software. We're delivering a service. And so we have to take the installation, the monitoring, the support, the deployment, the maintenance, all that, and bring that into the value stream. So we just tack it on in. And there's 2 boxes there, so we went from 5 to 7, and that's it. That's simple. Then we learned that DevOps is a little bit harder than that, and operations is a little more complex than that. And now it turns into about 10 boxes, and I put a line break in here because I think they're all in one. So we've extended the value stream, we've actually doubled it, and we end with that service. We have to do a lot more things in the middle to get to that service. So I purposely used a lot of the same words here because they're very similar tasks that you do to add value to this, to get to that end service. But a lot of what we think about in these systems, value streams is how do you improve them. So continuous improvement, you need identify those waste and just tack in the value stream. When you just tack it onto the end, you have a lot of duplication. So I circled 3 areas to try to make this simple. You can continuously improve the value stream. You can find small changes to this, or you could make a larger shift to your value stream. You could make slightly bigger changes, reorganize a little bit how your company does business. But unless you take a whole approach to changing the entire value stream and reinventing everything your organization does, you're going to be operating in some fashion like you were traditionally delivering that distribution software. And now you're delivering a conceptually different product. It's centralized, it's a service, it has different needs. We have different cost of change. We want small cost of change, we want to change more quickly. So you want to be able to react to those demands because that's what people want to purchase, that's what they want to subscribe to, or sub-license, or however you can do this. So if you were to take the largest approach of and reinvent everything, you would define a very different value stream to use DevOps and use these tools and capabilities and new types of technology that are available to deliver that service. So the same MBAs and the same computer scientists and the same software architects and the same executives that built that initial value stream would build something different. They would build a value stream. I'm going to hypothesize it looks more like this. And so I want to make the analogy between a highway and an interstate system. So this is an interstate system, and there's more lanes, and there's less congestion, and things move differently, and you still go through the same phases. You still add the same types of things to your work. You still plan, you still do development, you still do QA, you still deploy. But you would completely change what's in the value stream versus what's supporting the service of the value stream. So if I put these two next to each other on the same screen without any words, the pictures look different. A highway where you stop in every town and an interstate where you bypass those towns and just keep going. If I put people on here, you would put the people in different places, and they would have different skills and they would play different roles, and they would interact with each other differently. So I'm talking all about value streams here. What is DevOps? So I'm going to define DevOps as the transition from doing that value stream that created distributions of software to building a new value stream that creates services, modern services, different architectures. So where you start is going to be unique to your organization. Where you finish is going to be unique to your organization. If you ever start. So some organizations may not need to make a shift like this, may never need to do anything related to DevOps and still produce a product that is sellable and profitable and everyone's happy. The organization that is start doing DevOps and make some type of transition but not fully transition and still produce something that's effective and usable and everyone's happy and all that. You may fully commit to the whole movement, to the whole DevOps initiative, and you may completely get through this whole change we talk about, culture change, automation change, the calms, the claims, activity. And by the time you do that, you're going to be fully in a new value stream, and you may not use DevOps anymore. So you may have used it as a tool to transition, and now you're doing something new. And that's what turns set reliability engineering, full stack engineering become fun. And then if you have a new product that was designed from the beginning to be delivered as a service, you may never need to do anything related to DevOps at all because you never need to transition from something. So we talk a lot about tools, we talk a lot about automation, those are signs of improving technology, those are signs of continuous improvement, different methodologies, but DevOps to me is that transition, and you need to use it as such, and you're not trying to think about it as the end, you'll always do DevOps, you'll always work like that.
Thanks for that. And come back in again. Brian, thank you. I really like that. For each individual, it's probably going to be different. A completely different thing. And that's what I really like about DevOps in general, is that we can all define it differently. And that hasn't ruined the movement in any way. One quote I saw recently was, they were talking about the DevOps Enterprise Summit, and how the things that were shown at the DevOps Enterprise Summit were a lot different than this particular person than what they've been seeing at Agile Summits. When they go to Agile Summits, they see a lot of how. They see a lot of the things that you're supposed to do. And as practitioners in DevOps, a lot of times we're pushing towards results. And so by not having some definition that ends up being a really thick book of here's the steps that you have to take, I think that we've allowed ourselves to be creative and figure out ways to move faster, which is really cool. I'm going to now hand things over to Dave Swirsky for our news. And I'll get your slides up. You can introduce yourself. Here we go.
Hello, folks. My name is Dave Swirsky. I'm going to do DevOps news. 75% less fun than SNL news, 150% more related to DevOps. I told you 75%. All right. I know. That's because 2 buttons is too many. All right. So, starting off.
We got them flipped. Who knows Windows?
Is this Windows?
Well, I mean, who knows Microsoft? Yeah, but how am I going to
Oh.
Let's do this. Can you do the drop days? Yeah, you just don't have to.
Yeah, oh, yeah, I do it on my phone. Yeah, no.
Is there a swap thing up there?
There's a drop down on the play.
All right,
So yeah, maybe something up there.
there's guiding you.
There you go. Oh, up a little bit.
Up.
You're not. I can't see your mouse window.
Where did they go? The mouse.
It's not on there. Oh,
Do the mouse upside
to the
down.
right. To the right. Right. Keep going.
Really hard to do it upside down.
Up a little down.
We on it?
Yeah.
Think so?
Whoa! All right. All right. So, now I can't see. I have one. But I can't see the mouse.
Oh, you gotta get the mouse back.
Yeah, okay. I'll just go one at a time. Okay, cool. Okay. So the DevOps Enterprise Summit happened recently, and after that, Nicole Forsgren did her high-performing DevOps and IT organizations. And I want to call out the first one. I'm going to step out here to be able to read it. Can your team make large-scale changes to the design of your system without the permission of someone outside the team or without depending on other teams? I want to call that one out especially because it is a very common issue. A lot of places, the app dev teams, delivery teams don't have that kind of autonomy. Gaining that kind of autonomy, I think, is a core DevOps topic. And she talks about that. And for each one of these, there should be a link at the bottom. Oh, there it is. So there's a link to the video where she does a presentation about the summit. The next one. There we go. So on Cyber Monday, J.Crew had an outage. So they were down for at least an hour, and their Twitter was not really working very well, and their phone line wasn't working very well. Nobody could get through. So of the $6.7 billion generated on Cyber Monday, you can figure they probably lost at least a few $100,000 plus, irreparable priceless damage to the reputation. So you can imagine when it comes to outages like this, it's a big deal. So especially for retailers. Let's see. There we go. Okay, so Aurora. Aurora is the database as a service from AWS. It's been around for a while. And so if you have a transactional system with a relatively predictable load on it, then you can go out and get a MySQL Postgres database, no problem. However, if you have a bursty load, if you have to do flash sales or some kind of thing where you're going to have very high loads for a brief time and unpredictable, prior to this, back to use serverless Aurora, you want a lot, you're going to have a lot of unused capacity. Now, with serverless Aurora, you can do bursty workloads, you can get billed by the minute with like a serverless fabric type service. So if you have this type of workload and you use AWS, you want to check it out. Golden signals. So when it comes to getting metrics out of your data, out of your operational environment, I've used Swarm, Docker Swarm, just kind of want to check it out. And if I follow the instructions to feel better, it'll work great. When I try to use my own containers to do it, and everything seems to be lined up the same way, nothing wouldn't work. Which is okay, that our job is to figure that stuff out. When I'm ready to go look at why it was broken, nothing in the logs, at the containers would just start with themselves, and stop, and there was no information about why it was happening. So the SRE Golden Signals article here talks about what to measure, how to measure it, specifically related to the new technology, things like continuous orchestrators. Public language postponements. I used to play a game called Be Online, and at one point their servers went down. And CCP, the company based in Reykjavik, they did what they always do, which is they went down, they furiously got back up, and what did they do after that? Just business as usual? No, they wrote it up, and then they put it online. Public language postmortems is becoming a pretty common practice. GitLab has done it, Google does it, and it really goes a long way into holding yourself accountable as an organization. It also helps your clients learn better how not to do the same thing you accidentally tested. So a lot of good information here on what to include, what not to include, and so forth. Databases and containers. This is an article about a new relic, containerizing your databases, about why you would want to do something like that, and generally how they did it. It's a two-part series on putting databases and containers going. Next one. Okay, so very briefly, this is my opportunity to share a little bit of news relevant to myself. About a year ago, a little over a year ago, I stepped up to the mic at the DNO offices at DevOps KC meetup and did a quick Ignite talk about combining DevOps with code cutters. The code cutters are short little exercises to practice things you already know about software development, writing code. So I kind of went a little riff on it and said, what if we were to use cutters instead to teach you something new about, instead of writing code, using DevOps tools. So here we are, 16 months later. The pre-release edition is currently available on GitHub. You can go to DevOpsCutters.com. You can download the free Companion Learning Virtual Machine. Comes with a sample chapter, and if you got that far and you're still interested, you can go check it out on GitHub. It's available for a pre-release, early adopter price. So that is DevOps Cutters. And that is the news. Thank you.
Thank you, Dave. Did you go download that and get it set up? I played around with the VM a little bit. It's a lot of fun. So make sure you do that. And also, can you post those links in meetup notes at some point tonight or tomorrow? Cool. All right, with that, I'm going to hand it over to Randy to get going on microservices. The screens are awesome, except that you can't see them when you're up there. Is it up there? Didn't work straight.
All right, cool, thanks. Yeah, so I'm Randy Shoup. I'm the VP of Engineering at Stitch Fix. Who's heard of Stitch Fix? Wow, yeah, awesome. Great, thank you. I want to use my clicker for these seconds.
I thought we were going to play that game again.
All right. Okay, cool. I'm still Randy Shoup, still VP of Engineering at Everybody's still heard of it? Well, actually, now everybody's heard of it. So I don't know what it is. I'll tell you about it. And then I'm going to tell you about how we have migrated, or not migrated, are migrating, right, in the process of migrating our monolithic database into microservices. And I hope this is going to be, like, I could talk about this the whole time, but I know it all. So maybe if you guys could, like, ask questions along the way and, like, have it be more interactive, like, that would be more fun for me and hopefully more valuable for you. Does that make sense? Cool. And I have no great need to get through all the slides. You know what I mean? Like, we can just do what you guys want to talk about and whatever. Okay. So cool. Quick background about me. So like I said, I'm VP of Engineering at Stitch Fix. Stitch Fix is a clothing retailer, and we do a kind of different model of retail where you don't come and shop on our site. Instead, you tell us about yourself, and we send you things we think you're going to like, and I'll tell you more about that in a moment. Before that, I was sort of a roving CTO as a service, my friends used to say. I spent about 1.5 years helping companies think about this kind of transition and hopefully do it. Earlier in my career, I was director of engineering at Google for Google App Engine. So that's Google's platform as a service. People maybe have heard of that or used it, I hope. And then, yeah, like Snapchat runs on it, and Pokemon Go, and a few other things you've heard of. And then before that, I spent 6.5 years as chief engineer at eBay, and I spent most of my time there working on the search engine infrastructure. So cool, a little bit about Stitch Fix. So again, we turn retail on its head a little bit. So instead of shopping on our site, what if you had an expert do it for you? So you fill out a pretty detailed style profile about yourself. So height, weight, size, age, are you a parent? Do you like to flaunt your arms? Do you like to hide your hips? Like lots of information, lots of questions that we ask. And then we will send you 5 handpicked items in the mail in a box, handpicked for you by one of our 3,500 human stylists all around the United States. You keep the things that you want, and you will pay us for those, and then you return the other ones for free. So that is the client experience, or the customer experience. There's a ton of data science, actually, and software behind that. So we actually have a pretty unique, in the world, ratio of data science to engineering. So we have, when I joined 2 years ago, we had 25 engineers. We now have 125, and we have 80 data scientists. So that ratio of almost 1-to-1 engineer to data science, I think that's unique in the world. I've yet to find a company that is sort of does that same thing, at least at our scale. And so what do we do with all those data scientists? Well, it turns out that if you're smart, it actually pays. And so we apply intelligence to every aspect of our business, right? So we have people that buy the clothes, and we have data science and tools that help them figure out what to buy, in what size quantities, when should they arrive, what warehouse should we store them in, et cetera. We do inventory management, so we try to figure out how to best store things in the warehouses, and when somebody's picking those 5 items in a box, we route them in a not optimal, but a decently optimal way through the warehouse. For computer scientists, that's a traveling salesman problem. You guys are familiar with that. So routing somebody, like picking like 5 arbitrary items out of the warehouse and choosing the optimal route, like you actually have to enumerate all the possibilities to find the optimal solution. Logistics optimization, we physically store things in warehouses, we physically ship them through the mail. We would like them to show up on your doorstep when you want them, but at minimal cost to us. The styling recommendations, which I'm going to talk about in a moment. So those are the recommendations that we make to those 3,500 stylists about what we think you're going to like. And then we do demand prediction. So we're a physical business. And so unlike eBay and Google, where I used to work, like those are virtual businesses. And so if we had 2x the amount of customer load that we were expecting, like we'd have a party. If at Stitch Fix we had 2x the amount of customer demand, that would be a disaster, right? Because it would mean we only have half the inventory to serve our clients. We only have half the warehouse employees, half the stylists, et cetera. So we need to be pretty, as I'm sure many of you do, we need to be a little bit more, rigorous about predicting our demand. And in all these things, it's sort of humans and machines augmenting each other. So again, as I mentioned, your experience as a client of Stitch Fix would be, well, obviously Stitch Fix has a bunch of clothes, and they send it to me in a box, and I open them, and I'm happy. In between that line, there's actually something that happens in there. So the first step is that we do a ton of personalized recommendations based on data science. So this is what many of those 80 data scientists are working on. So every day, we take every piece of inventory times every client, and we compute a predicted probability of purchase. What is the likelihood that if we send Randy this shirt, he will keep it? So, all right, 62% chance for this shirt for me, 57% chance for these jeans for me, and then, 42% chance for the shoes. And those numbers are going to be different for everybody in the room. Does it make sense? So personalized recommendations, the combination of this piece of inventory times this particular client. And so those algorithmic recommendations, those scores essentially, become the ranking function, or the way that we order the search results for the stylist when they're choosing the clothes. Does it make sense? So the stylist goes like, I want to find Randy a shirt, and the shirts are ordered by those personalized scores for me. Does it make sense? And then when they're looking for you, they're ordered by scores for you. And so that human, you say, curation step, right? So there's a bunch of machine-driven recommendations, and then humans curate it, and then at the end we pick 5 items that are going to go together in a box. Cool. So the genesis of part of this talk, the sort of first part about why would you ever decide to do this crazy thing called microservices, was sort of this kind of conversation. So when I did that roving CTO as a service gig, people would be like, hey, you worked at Google and eBay, tell us how you did it. And I'm like, sure, I will completely tell you everything we did, but you have to promise not to do it. Why? Why did I say that? Not because I'm mean, or because they only work for those other companies, but basically they only work for those other companies. I mean, a 15,000 person engineering organization like Google, there are going to be practices and tools and mechanisms of working that are going to work at that scale, and they are not going to work in the same way at the 150 person scale, or the 15 person scale, or the 5 person scale. Does it make sense? Cool. So I will tell you a little bit about some of these evolutions. So companies you've heard of that started as a monolith and then have over time retooled their infrastructure to do what we now call microservices. So eBay, depending on how you count, is on its 5th complete rewrite of its infrastructure. So the famous story was in 1995, Piero Midyar, the founder, spent a Labor Day weekend, so a 3-day weekend in 1995, playing around with this new cool thing called the web. And he basically built the first version of eBay out of Perl, and it ran. I always want to say it ran on his own laptop, but I'm sure it was not a laptop. It ran on his 486 tower that he had under his desk or whatever. So something that he had in 1995, but it was written in Perl, and it wasn't intended to scale. It wasn't even intended to be a business. The next generation was a monolithic C++ application, which at its worst was 3.4 million lines of code in a single DLL.
Whoa.
They were hitting compiler limits on the number of methods per class, which is 16K. So yeah, who has a monolith that was worse than that? Yeah, not too many. It's pretty bad. So the next iteration, this wasn't about C++ versus Java, but the next iteration, they rewrote it in Java, and you really couldn't call it microservices, but sort of mini applications. Does it make sense? So each different like page or section of the site would have its own Java application, right? So they'd do one for search, one for selling, one for buying, about 220 different, individual applications. And then now it's fair to characterize eBay as a polyglot set of microservices. So Twitter has gone through a similar evolution. It's on about its third generation today. It started as a monolithic Rails application, which they codenamed the monorail. The next generation was breaking a bunch of the front end out into JavaScript, a bunch of the back end out into services. Twitter was really early adopters of Scala, so a lot of their early services were in Scala. And now Twitter you could call a polyglot set of microservices. Amazon has gone through a similar evolution. So Amazon, when it started out, was a monolithic Perl and C++ application, which you can actually still see evidence of in a lot of the URLs. So if you've ever seen Ovidos, O-V-I-D-O-S in an Amazon product URL, that is the code name of the original monolithic application. Why do you think they still have them in the URLs?
It's still
SEO. No, it's not still running. Yeah, it's still up there. No, the model is long gone, but the URLs stay around because search engine optimization, right? Because they've gotten so much page rank associated with that page that I'm making this up, but like the Little Prince, like something that like they've been selling for 20 years or whatever, like that they want all the page rank that they built up over those decades to still end up at that page. So that's why they keep the URL, even though the application's gone. So then the next iteration, which was a service-oriented architecture re-architecture, and it took them basically 2000 to 2005. And it's hard to remember. Anybody here in retail like me? Yeah, wow. So maybe I'm the only Amazon competitor in the room, but like if you're in retail, if you don't think you're an Amazon competitor, you're not paying attention. Like everybody in retail is an Amazon competitor today or tomorrow or next week. And so it is hard to realize in 2017 that like Amazon's business was actually not doing particularly well from 2000 to 2005. And Jeff Bezos, like really brilliant CEO, said, Wall Street, I am not interested in you keep complaining, but go away, because I'm going to spend as many years as it takes to rebuild this, to like undo this monolith and rebuild it in a service-oriented way. And look what's happened since then. The subsequent 12 years, Amazon Web Services, everything about the retail site, they've entered everything retail on the planet. The two things they had not done at the beginning of 2017 were grocery and clothing. Grocery, all done. Clothing, getting there. So yeah. Anyway, now you can call them a polyglot set of microservices. So is there a pattern here? Does this look like a familiar pattern? Yeah, so here's the pattern. It's nobody starts with microservices, but past a certain scale, which legitimately not everybody's going to reach. Like legitimately, maybe 95, 99% of companies are not going to be at the scale where you absolutely can't live without microservices. But past a certain scale, everybody's going to end up with something that we call microservices. It is possible that in 1995 there was an eBay or Amazon competitor that instead of building a monolith and delighting their early customers, instead they built a distributed system. Like that's possible. If that was true, there's a reason why we've never heard of that company. Right? Because they spent all their time like building technology and not solving real problems. And you should be so lucky as to get to re-architect later on. Does that kind of make sense? Yeah, cool. So I feel like I'm going to talk about microservices quite a lot, but a lot of people are like, hey, I don't think microservices are for me. I'm like, great, that is cool. I agree, and so does Martin Fowler. So Martin Fowler, the refactoring guy, he's amazing. I love his first blog, Distributed Object Design, which is don't distribute your objects. So only do this stuff when you absolutely have to, and then I'm very happy to give you all the techniques that we've learned at Stitch Fix, at eBay, at Google on how to be successful. This is how I like to say it. If you don't end up regretting your early technology decisions, you probably over-engineered. Because if there's a thing that you did 5 years ago and like you're only now kind of getting the benefit of it, like that was a waste of time 5 years ago. Like now you need it, great, cool, you should build it now. Or maybe a year ago or something if you could predict that you're going to need it. But the idea that and I have this place in my heart too, where like as an engineer I look like, well, why did eBay build that terrible monolith? They're a super fast-growing business. Like, that wasn't their problem to solve. Like, later their problem was, the monolith is a problem. But their first problem was like, oh my God, there are so many Pez dispensers that people want to buy. You know, they just had to deal with it. So yeah, I mean, I'm just a strong believer in being super pragmatic about it. Like, just build the technology that you need and look ahead, but not look ahead 5 years or 10 years. Look ahead the time horizon you can actually see. And if you're a startup, maybe that's 3 months or 6 months. If you're a larger company, that's maybe a year or two, something like that. But I don't see a strong even for companies that do last for decades. Their problems change and their business models change. And you shouldn't assume that you're going to know today what you're going to need in 2027. Okay, so let's imagine that we actually do want to do some microservices. So when I say microservices, what do I mean? So the micro in microservices, to me, is the scope of the interface. So it's not about the number of lines of code, and it's not about how long it takes to write it. So I've seen people, a couple people like, I don't know, blog about like, oh, microservices should be like less than 200 lines of code. Like, I don't know. I could write, a payment microservice. That's like a totally legitimate microservice. If you could write me a payment system in 200 lines of code, that's awesome, but unlikely. It's not about how many lines of code it is. It's about, again, having a simple, well-defined interface that does a particular thing and does it well. So it should be single purpose, simple, well-defined interface, and modular and independent. And if this looks very similar to service-oriented architecture, you would be right. I am old enough to remember, the first iteration of service-oriented architecture in like the 1990s, and microservices are just service-oriented architecture done well. In other words, done where the services are granular and well specified and single purpose. And so the implication that has, and we're going to talk a little bit more about this and the implications of it going forward, but the implication is that in an effective microservices architecture, you do not want to share databases. Why? Because if there is somebody, if I have my service A or whatever, and B or C or D can come behind my back and read and write from my database, what possible mechanism do I have to guarantee any invariance or any business logic executing? Right? Not at all. Does that make sense? Yeah. And I've been there. Like, eBay made this mistake in 2008. So eBay did a service-oriented sort of re-architecture or attempted one, and it was, and the people were very smart. They built these really well-designed service interfaces. They thought very carefully about it. They were not, at all stupid. They built great services. Nobody used them. Why? Because they could still go to the shared databases. Right? There was no, like, my stuff still works going to those databases. Why should I use your service, Ryan? And you're like, because it's cool. I'm like, yeah, but my stuff already works. So that was a failure because we did not, there wasn't a thing where you could still get to the services underlying data without running through the service interface. Does that make sense? Yeah, cool. Okay, so I'll talk a little bit about what I mean, some examples of what I mean by isolated persistence or persistence that's owned by the service. And then we'll go further later on and talk about what are some of the implications, because there are some wonderful things about having a monolithic database, things like joins and sharing data and transactions, and I'll talk a little bit about what you can do to solve some of those problems in a microservices world. So I hope that'll be interesting. So it'll kind of give you some food for thought about how you might be able to still retain some of those things you like about the monolithic database. Okay, but on the persistence side, so now I'm a microservice, and what are my options for like having my own database? Well, obviously I could just run it myself, right? So the same team that builds my microservice could also own and operate, my own version of my own instance of MySQL or Postgres or Oracle, or even like a slice of a larger Oracle, right? Like some particular, I have my own user or something like that. Or if you have access to cloud-based stuff, I could use a persistent service, right? So maybe somebody could operate a multi-tenant persistent service on behalf of me and somebody else. So, Aurora, which was mentioned in the news, is one of many examples. So Dynamo or relational database service from Amazon, from Google, where I used to work, this cloud data store and MySQL and all that kind of stuff, Cloud SQL. Anyway, so a bunch of these different things could be operated on your behalf by another team that works at your company or another third party that you use. And the key thing I want to say here is that the key idea is that we were trying to say before, that the only external access to your data store needs to be through your public service interface. Does that make sense? Cool. Okay. A little bit about pros and cons of microservices. Then I want to talk about the decision to maybe re-architect if I have a monolith into microservices. And then, assuming we have made the decision to do microservices, I'll talk about the implications of that. So, obviously, lots of people who talk about microservices are talking about why they're great. So, maybe you've heard the pros part. So, each individual service is very simple. You can independently scale them. You can independently tune the performance. A thing that's not well appreciated until you've lived in that world, like it's actually a lot easier to independently test the microservices if you build them well because they're small and independent. Like, I mean, if you build a good, like, simple interface, it's easy to test it from the outside. Like, you can do black box testing from the outside and get a lot of benefit from it. And then also, not as fully appreciated is when I have a monolithic database that everything's in there, if I want to introduce a caching layer on top of that, that's really hard. In fact, it's so hard that if we were having this conversation, I don't know, 7 or 8 years ago, we would remember data grids. There was like gigaspaces and coherence and a couple of companies that were around that space. I actually genuinely like and respect all the founders of those companies. They were very, very smart. That is an intractable problem because essentially that cache in front of a really complicated database schema is what? A replication of the database schema not in the database. Like, it's a really hard problem. And so that's why nobody uses them anymore. Not because they weren't smart people, because they had smart people banging their heads against the problem that was basically insoluble. But if you break that monolith down into smaller microservices, now you can put caching in front of it, and it's really easy, right? You just cache the reads for the particular microservice, and you're not worried within the scope of that service all the interactions between this entity and that entity and that entity. Does that make sense? I see a few nods of grizzled veterans that have done that. Cool. And I would be remiss if I didn't say there are cons to microservices. There totally are. So each unit is simple, but like there are lots of cooperating units. So that's the model that we live in when there are microservices. Rather than maybe having like one single repository where it's super easy for me to do broad-based refactoring, typically when people implement microservices, there are often a lot of small individual repositories of code. So sometimes, cross-cutting changes to code that can be more difficult. It definitely requires a lot more sophisticated tooling and dependency management between the services. And then now you have replaced those beautiful, very fast in-process latencies inside your monolith with network latencies between the services. Does that make sense? Yeah, cool. All right. Well, microservices, like, they're good and bad. Like, I don't know. Why would we want to re-architect? Well, I've got 3 thoughts for you. For 3 reasons that I've seen companies decide to make that leap. The first and foremost is, I'll call it feature velocity. So typically the problem statement is, wow, that monolith is so painful to work in. Like, it takes me months to like get a change into production. Another warning sign here is like, if you bring new people onto your team or into your company, that it takes them 3 or 4 months before they can check in any code that doesn't break stuff, right? Because it takes them that long to learn where the bodies are buried. Like, yeah, I see lots of guilty smiles. Yeah, no, I mean, like, I've definitely lived in that world myself. And that's a thing, right? That's an actual thing. That's an indication of some problem. And we can solve, there are other ways to solve it potentially, but that is, I've seen lots of companies see that as a warning sign and think, oh, wow, we really need to break up this model. Cool. Another one, and this was eBay's argument, honestly, even more than the feature velocity, but the scaling. So, eBay was scaling really quickly, and they were just buying bigger and bigger machines that Sun Microsystems was selling, at the time, and then like basically they bought the biggest. Yeah, I know. Old people remember Sun Microsystems. Yeah, they're great people, by the way. Anyway, so like they were buying the biggest big iron that Sun sold, and like, okay, we need the second. I need one that's twice as big, and Sun's like, I don't have one. And so then they're like, okay, well, I guess we better like make 2 of those big things. So, so that was, to be honest, that was the genesis of why eBay had to break up its database, because they literally were buying the very largest machines Sun sold, and that was still not enough. Cool. And the other angle here is a lot of times it's not the scaling of the entire system, but there's one part of the system that has a scaling vector that is really, really fast, and other parts of the system just don't need to scale at that same level. Does it make sense? So, so the idea of breaking a system down into smaller components or smaller microservices allows you to scale some things like really big and really wide, and other things don't have to grow at the same rate. Does that make sense? Yeah, cool. And then the last one, and this is rarely anybody's first reason, but it is almost everybody's second reason, which is deployment, right? So being able to deploy different parts of the system on different cases. So probably once you have written your, I don't know, authentication or authorization system, like that probably doesn't change very often, to be honest. And that's good. Because probably you spend a lot of time making sure that it works and it's highly secure and everything. But there are lots of other things, like every part of your front-end website, like that's changing all the time, right? And so why am I deploying like the authentication stuff when all I want to do is like update some JavaScript or something like that, right? Cool. So if we have decided to do some migration, so we're like, okay, Randy, I agree, monolith, like we want to get to microservices or something that's less monolithic. Here's what I would recommend not doing. And again, I would quote Martin Fowler because he's so clever. The only thing a big bang migration guarantees is a big bang. So I would very strongly recommend not to do it in one go. Instead, make it incremental and like carve one piece off. Often, interestingly, I've seen this. Actually, I was just talking with a company in New York yesterday. Probably shouldn't say who it was, but a place you've heard of. And they're like just getting started in doing microservices, and they do the payment system first. And for some reason, people really like billing, taking payments or billing out of the system, because I guess people really care about money and they like to scale and stuff. No, I mean that makes sense. But a lot of the first initial microservice abstractions I've seen is in that particular area, because it has I think often because people really care about it and they want to evolve it really quickly, and because the interfaces, when done well, are actually really simple. The implementations are super complicated, but the interface of Randy wants to pay Aaron $100. That's a pretty simple interface. The actual way that the money gets extracted out of my credit card, it travels for 3 days around the world and then into Aaron's pocket, like that's really complicated. But, yeah. Cool. Does it make sense? So far? All right, cool. So now I want to shift a little bit into some things that we can do while we're in microservices, and that can solve some of those big data problems. And I need to kind of give you a few architectural tools that I hope you already have, but I'll remind you that you have them, and then we can kind of dive in. So the main architectural tool that I think everybody really should have in their toolbox, if they're going to move to something like service-oriented architecture from a monolith, is some concept of events or messages. So who would say that their system is somewhat or a lot message or event driven? Not enough. But that's cool. That's cool. We'll get there. So an event, says Wikipedia, is a significant change in state. I like to say that it's a statement that something interesting occurred, right? So item added, customer checked out, address changed, something like that. A statement that a fact happened, and then there are maybe nobody or maybe lots of different places in the system that are kind of subscribing to or listening to that change. So a lot of us, I mean, certainly, look at me, I'm pretty old. I cut my teeth on the standard 3-tier architecture, right? So there's presentation and sort of application or business logic, and then persistence, which is typically a relational database. I'm sure lots of us, in the room, go to systems like that. There's nothing wrong with it. But I feel like we're missing something when we don't have a first-class idea of a state change, like a state change. I'll call it an event, you can call it a message or something like that. But having a first-class construct in your architecture, in your kind of design thinking that represents a state change, that really helps a lot. And interestingly, events actually represent how the real world works. So in finance, in our software development process, for example, any workflow can be represented by events. So for example, let's do this. So a bunch of us write software for a living. Raise your hand if when you hit return in your IDE, it is immediately and atomically deployed to production. Nobody. And that's impossible because a software development process is actually a workflow. It's actually a process, right? So you have hit return in your IDE, and you've maybe built your thing locally, so that's like a little event or a little thing that happens, and then you maybe deploy it to a test environment, and you do it there, and maybe you deploy it to some continuous integration environment, and then at some point, way down the line, you actually deploy it to production, but like those are the steps. There's a whole process that you can model as events that go along with it. Does that make sense? Yeah. Trying to use, real things that we do actually every day. Cool. So I want to talk about how events would apply to microservices, and then we're going to use that as a technique when we try to solve some of these big data problems. So I like to think of, when I have a service interface, I like to think of events as being a first-class part of the interface. So what do I mean? Well, so if I have a service, it's pretty obvious that the interface includes that kind of front door, right? It includes that synchronous request response, like whatever it is, REST, JSON, or gRPC, or Corba, or SOAP, or whatever. What else? Decom? I don't know. Anyway, but it certainly includes that. But it also includes like any events that the service produces, yeah, any events that the service consumes, and also any other like bulk reads and writes. Like if you're bulk reading out of your database to put it in an analytical system, or maybe you're bulk updating things or something like that. Like that's also part of your interface. And I like to think of it as the interface to my service includes any mechanism that gets data in or out of it. Does that make sense? Cool. So when I add events, I don't want to like forget about them when I'm sort of designing my interface. Like the events are part of it. And that's actually something you can test. Like when you test that service from the outside, you can say, oh, I do this thing to the front door, and I expect this event to squirt out inside. And you can test to see if that happens. Okay, cool. So now I want to talk about that incremental stage, the incremental like breakdown of a monolith that we're doing at Stitch Fix. So our problem is that we have a monolithic shared database. We did not actually build a monorail. So we never built one monolithic application, but we did absolutely and intentionally, construct a monolithic database. And like everything that's interesting about Stitch Fix is in that database, right? So everything we know about clients, everything we know about those boxes that we send, everything that we know about the items, the physical items that we have in inventory, all the metadata about the inventories in there, everything is in there. And as you can see, we actually have 70 different applications and services and 175 tables in this database, and so I can't even show all the boxes in mine. But you guys have even more complicated stuff than I do, I'm sure. Anyway, so what I want to do is I want to decouple applications and services from that shared database. Does that make sense? Like that's a problem that I want to solve? Okay, cool. So I'm going to shrink it down just to make it even, like so there aren't even so many boxes in mine. So let's imagine we have just 2 applications and there are 3 tables, and each of them is using all 3. Okay, so the first step is we're going to create a service about clients. So it's going to have ways of adding clients and maybe changing them and reading them or whatever, and that is going to be that's going to use this client table as its persistent store. Okay, so now we want to. This is actually a lot of work, but we want to just simply point those applications at that service. And we're all laughing because that transition from here to here, that's a lot of work. That's person months of work, maybe person years of work. But it's work. That's what it takes. Like if we're going to break up the system, like that's what you're going to have to do. And so once those applications are using the service, and it is only the service that's using the table, yeah. So now we can move on to the next thing where we can actually extract that table out of the shared database, put it into a database that's sort of associated with the service. Does that make sense? And again, I do not want. Just because as an architect, like it's super easy to move the boxes and lines around. I just don't want anybody to think that that's easy just because I can move a line. But these are the steps, right? You have to first create this. You can't do anything until you create the service. Just what are the applications going to use before that, and then you have to do the careful work of decoupling and spaghettifying the code that uses clients from those applications that use the service. Okay, great. And now again, so simple. We just rinse and repeat, right? So now we're going to do the same thing for this item table. We're going to do the same thing for this SKU or style table, which is like the metadata we have on our inventories. And what I want to emphasize is that these are actually the service boundaries. Does it make sense? The service boundary is the application part, the business logic part, but also the data, right? So there's no, there should be no way for anybody to backdoor get into one of my databases. Does that make sense? Cool. Nobody has yet had a question or a comment, so great. All right, cool. Please. What if you have separate report writers? So the report writers are essentially joining across all the different tables-ish. Yeah, I think there are two ways to do it. One we're going to talk about in a few moments about creating services that would sort of materialize join. Another way, if you're literally doing analytics and reporting, often in these systems you do end up like ETLing out of the individual databases and putting it in some analytical system, but that's not an operational system, right? So the operation systems are like this, and the analytical system is something that takes often some subset, to be honest, but like some subset of that operational data and then makes it available. And like that pattern of, oh, I have operational systems and then I have analytical systems, like probably we already are doing that. Like most people are not using the same exact maybe Oracle database as for their operation system as for analytics, right? Because it's a very different database design, it's very different optimization strategies. But yeah, that's what I do. Cool. Yeah.
So when it's a good design talks about you say use bond.
Oh, gorgeous. Yeah, so domain-driven design talks about bounded contexts. Are these bounded contexts? They sure are. Exactly right. Yeah. The ideas behind domain-driven design are so helpful. They predate the word microservices. Like Eric Evans wrote that book like 10 years ago, 15 years ago. He's brilliant. And yeah, I say this to him personally, so I won't talk behind his back. Like, his wording I find really impenetrable, but his ideas are really great. Like once you can understand what he means by aggregate, what he means by bounded context, like, oh, that's a really great concept. Terrible words, like great concept. Yeah, exactly. Yeah, other definitions I've seen. So Adrian Cockcroft is like super famous in the microservices world. He was at Netflix, and now he's at AWS. And I forget the exact wording, but he defines a microservice as like a service-oriented, bounded context. So he's very intentionally using domain-driven design terminology. Yeah, that's a great point. I love to set that. Yeah. What kind of mix between synchronous and asynchronous? Yeah. So what I'm showing here is synchronous, but like actually, hold your thought on asynchronous stuff. No, it's great. Why would you? How do you not know what my slides are going to be? No, seriously. I'm going to talk about events and asynchrony like. So no. Let's get to the end, and when I probably have not answered your excellent question, but you'll ask it again. But the reason why I talked about events is like that's going to solve a whole bunch of the problems going forward. So the idea of having, for example, this client service know that things have changed about clients because it owns the client, and then it produces events when those things have changed and other people subscribe to them and interesting things happen. So we're going to use that in just a moment. Yeah, great, thank you. Wonderful segue. Any other thoughts or questions at this point? Yeah, please.
I might have missed somewhere along the way. What was your motivation or Stitch Fixer's motivation for this pattern?
Yeah, great. I didn't say. It was the feature velocity one. Yeah. So for us, no, that's actually a lie. It was that it was a single point of failure. That's why. So a year ago, that shared database. So everything in Stitch Fix depends on that shared database, right? Like all of our applications internally and externally. And for various reasons, it was actually going down. Like if we were at kind of lock contention and everything was slowing down, and it was rapidly reaching a crisis situation. And I'd seen this pattern before at other places, and so I said, "Hey, everybody, this is just the beginning. Like sometime in the next month or two, we're going to have a serious problem." And so we actually did. I wasn't planning on talking about it, but I will answer this briefly. We did a three-pronged approach where we solved. We're using Postgres, which has connection limits that no other database has. So we had to solve problems around managing our use of this scarce resource of connections to the database. That was the thing that we did. And then we also had to monitor all of the expensive queries that we were issuing. And then every time we saw something that ran for longer than a period or held blocks for longer than a period, we would go try to figure out a way that it wouldn't do that anymore. And the details, like, there were details that were different either way, like optimize the query, don't do it at all, break it up into two things, like that sort of stuff. But those were both very immediate solutions to the problem. And then the longer term solution is what I'm talking about here, which is, okay guys, and when I say guys, I mean, okay executives at my company, this is I laid out this whole program, and like, we're going to have to do this, and here's why we did it, here's why and how we did it at eBay, here's why and how they did it at Amazon, Netflix, and other places. You're going to have to give me 25% of resources across the board to do this, and that's what we do. That's a long one. But yeah, the trigger point. I mean, I've been talking about it to the team for a while. We're going to have to get to this point pretty soon, and I was talking about it with feature velocity language. But the actual trigger point was the constant failures. Yeah, great. Cool.
So that means part of your app can be functional to users when there's a partial database failure?
Yeah, so that's actually our definition of done for one of these pieces of work. So again, we don't do it in all one go. I have iterated it in a good DevOps way. We've iterated our way to the model I'm about to say. I can tell you our failures along the way, going this way, but our current model of how we approach these things is we say, here is a business, here's a customer visible thing that we want to be resilient to the loss of a shared database. So for example, I want customers to be able to check out on our website even if the shared database is not fine, as an example. Or even equally aptly, I want to have we're a consumer business, so we do outbound marketing, and we want to bring people to the site so that they can become clients of Stitch Fix. If they come to the site and the site is down, that's not a great experience. And so a thing that we've also worked on is make that initial homepage sign-up experience resilient to the loss of the service. Does that make sense? And it's taken a while to get to the point of that, but in retrospect, it's completely obvious. But take this actual thing that is meaningful for our end customers, and meaningful for our product people, meaningful for our business, and say, I want to make that survivable in the case that this other thing is in trouble. Does that make sense?
Yeah.
Yeah. And then you get, when you do that, the business people and the product people get it, because I've now expressed it in a way that's not technical and infrastructural, but very functional. How do you feel if your Google ads are driving people to the site and they can't sign in? Randy, that's a disaster. Right, I agree. So here's how I'm going to solve that for you. And it also focuses our work, right? Because it's not like let's servicize everything or whatever, servicify everything. I have this very clear objective, and what are the implications of that? I need to make sure that the login is survivable, and I need to make sure that the authentication piece is survivable, all that kind of stuff. We are all 100% cloud. Yeah, so we have the benefit of being more uniform than horse. So we started only 6 years ago, so we've never had a piece of physical infrastructure. And I don't say that because but no, we just never did. We started in the cloud era. Yeah, I mean, I've definitely worked with other thoughts. I've definitely worked at eBay. It's all on premise. It's too big to do anything otherwise. Actually, obviously, Google internally also on premise. Think about it. Yeah.
So you have two apps there, and when you broke out the service, both lines switched to the service at the same time. Is that what you did in practice? Or
yeah, you switch them over one by one.
How did you migrate them one by one?
Pretty much, yeah. I mean, the thing is, we organize ourselves around a team owns a particular application or set of applications or set of services, right? So, we have teams that have a part of the business that they're responsible for. And why do I say that? You actually, in this particular example of the styling app and the warehouse app, they're both different teams, so they actually could do that migration in parallel. Does it make sense? Because they don't really coordinate with each other. Once the team that has built the client service has finished that interface, or more precisely, once they've gotten it good enough so you can start integrating with it, right? Then the other people are unblocked and they can use it. Does that make sense? Yeah. Typically though, it's good to build, when you're building a service for the first time, it's good to do it in lockstep with at least one user. 2 is even better, not 10, but like, because then you'll squeeze out all the places where you messed up the interface, or like you did stuff that they don't need, or you didn't do stuff that they didn't need. Especially if there are 2 different use cases. Yeah.
Okay.
Yeah.
Did you plan for load on those services as teams move over? Did you plan for load, or did you just?
Yeah, we plan for load. I mean,
I think it was a cloud.
Yeah, well, that cloud doesn't all go away, but I mean, we did auto scale it, so from that perspective, yes. But I mean, the load is more of the database load anyway. And remember, let me just go back. It's still the same table when we moved everybody over. Does it make sense? So like we started up here where we added the service like on the side, and then we moved the apps to using it. But the service is still using the table. So in many ways, it really conceptually it ought to be the same load. Like there ought to be the same number-ish of operations on the database. I mean, depending on how efficiently you do the service, but for the most part, it's the same number. Yeah. Yeah. Yeah, how does it impact database replication? So, yeah, I mean, so we do have a Postgres model is a master and multiple read replicas, and so we have continued to do that. For a while, for some values, we thought it was a good idea. We thought we could live for a while of taking the writes to the write master, but the reads to the replicas. Conceptually, that one could imagine that working, but the replica lag, if it's longer than a tiny set of milliseconds, is really challenging for people to deal with. And so, yeah, but that's actually, to be honest, that's a separate thing from the service stuff. But yeah, do you have a specific worry about it, or just wondering? No, yeah. Yeah, no, I mean, well, obviously, once, I mean, in this model, there actually are legitimately like separate instances. You know what I mean? Like that's why I draw those boundaries. Like we implemented it like they're totally separate instances. Yeah. Is Postgres an engineering decision I'm regretting? Oh, that's a clever question. Not really. I like everything about Postgres except their connection management, to be perfectly honest. No, I mean, I'd say this to anybody, even if I knew the Postgres people, I would say that to them. Like, it's a very, I mean, it's free and it is as feature rich as most of the enterprise class databases. Like they really spent a lot of effort on. It is very high quality, very non-buggy, very feature rich from a relational database perspective. Like MicroSQL has other wonderful things, but from the perspective of like simply sophistication of the SQL, Postgres is like way ahead of MySQL, for example. But yeah, the sucky thing, and sorry, this is the thing that bugs me, anything else, but like, it's so well architected, so well designed, except it is a process per connection model, as opposed to, like, dude, that's what Oracle did when I still worked there 20 years ago. And they discovered this new cool idea of threads, like, 20 years ago. And so, yeah, so the way that you deal with that in Postgres is there is another third-party thing that you put in front of it that is a connection concentrator that turns the process for connection into a thread for connection model, and that's how you do it. But like every other database on the planet already has that baked in. So nobody's like, oh, I'm worried about a number of connections to my MySQL. Like, nobody worries about that. Like, that's not a thing because there's not that much. They're not heavy. Good question. Yeah.
I heard you bring up Fowler a couple times. Would you describe what you're doing here as a strangler pattern or something different than that?
So I would not describe it as a strangler pattern because what I'm not doing is, so a strangler pattern is, if people are not familiar with, so Martin Fowler and like ThoughtWorks, they always have to come up with these cool names for things, and they talk about a strangler pattern, which is, there's a thing in Australia, a tree called a strangler fig, and it drops, somehow a seed gets dropped at the top of the tree, and then it the strangler fig grows down around the other tree and ultimately kills it. And so you see it where like there's kind of like columns of a tree and then emptiness in the center. And the center used to be some other tree that it grew around. Anyway, that's the idea. The idea there is if I have a monolith, I want to put one of these strangler guys in front of it, and then I can slowly maybe move pieces of my monolithic application out, and my clients wouldn't be aware. So I'm just telling you what the model is. This is my answer makes sense. No, we didn't use that because we don't have a monolithic application. So our applications, we already had separate applications. So we're solving a different problem, which is service extraction from the database.
So then my next question, and I have a feeling it's probably in future slides, do those services that you have on the screen so far have to call other services to make up for, it's a relational database underneath, right? So there's probably foreign keys on, like these, these tables are not separate.
So, I see why you say that. It is, I'll say several things. It is completely legitimate for services to call each other. Like that is not breaking any abstraction or any rule. You can't talk to the AWS database, but you can absolutely talk through your services. Like that's legit. These particular services, in this particular example, none of them use other services. But look, they're really low-level engines, right? Yeah. So like client, if I'm asking client about itself, there's probably not a lot of things I need to know. Like client shouldn't have to go ask other things to know about client, probably. There are other tables, there might be a whole constellation of tables around client, right? So like I might do my ER modeling and like, okay, there's a main table and there's attribute tables around the side. Like it doesn't have to be one service per one table, but like a service per entity is a good thing. So I mean, in these examples, these are all pretty low-level shared entities. But we do have, for example, a service that backs our mobile app. So we do the standard like backend for front-end patterns you might have heard of, BFF. And that is a common pattern where that service is very thin and wide, like it has very little logic, but it sort of is a router or dispatcher to a bunch of backend. Cool. All right, let's go. Okay, so now we're in this model where we have taken our wonderful monolithic database and we have broken it up into these smaller databases. But Randy, I loved when I could have shared data and joins and transactions, and you took those all away from me. Let's see how we can get some of those ideas back. Looks like I already did this thing. Sorry about that. Okay, so I want to talk about shared data, then joins and transactions, and then we can do some more questions. Okay, so the problem statement is this. In a monolithic database, it's really easy to leverage shared data, right? I just point at some shared table and I'm good. Where does shared data go in a microservices world? So there are a couple of different potential approaches. But first I have to give you one more kind of architectural philosophy. So I like to think of, if there's anything that's interesting in our system, there should be one and only one place in the broader system that is like a system of record for that entity. Right? So there should be one place in my system that owns customer. There should be another place that like owns item. Does it make sense? There are lots of other places that know about customer, like my fulfillment service needs to know the customer's address, for example. But the fulfillment service doesn't own the customer, and my customer service does. Okay, so we're going to use that as we go forward. So there is one and only one place in my system, conceptually, that owns a particular piece of data. That's like the canonical system of record for it. Every other place in the system is, and these words are all important, is a read-only, non-authoritative cache of that information. So if you're familiar with DNS, like that's exactly this. If you're not, I'll give you more examples. So every other copy of the customer data, like every other little slice of the customer record that is used in other areas of our system, that is read-only, right? So I shouldn't be able to update the customer's address like from the fulfillment system. Does it make sense? It's also non-authoritative. So if the fulfillment system allowed me to ask it what's the customer's address, that's not authoritative. Like that doesn't tell me the current address. That just tells me the cached address that the fulfillment service happens to have at this moment. Does it make sense? Cool. Okay. So now that we have all those tools in our toolbox, 3 different approaches for shared data. So the first is just look it up when you need it. Like that's pretty straightforward. And we do this all the time. So in this example, our fulfillment service wants to know a customer's address. It simply asks the customer service in real time, what's the customer's address? It tells it all that. Like, that's totally legitimate, and we do this kind of thing all the time. Sometimes this isn't the right solution because maybe that would be too many queries to the customer service. Maybe I don't want to, we say, couple the availability of the fulfillment service and the customer service. Like maybe we'd like the customer service to be able to go down, but we still could ship things to people. So maybe there are reasons why we don't want to do the synchronous lookup. So then we can use this technique that uses asynchronous events. That's your question, sir. So in this example, the customer service owns the customer data. We're going to produce an event when the customer's address changes. The fulfillment service is going to listen to that event and then update its own local cache of the customer's address. Does that make sense? Cool. Yeah.
So you still need a fulfillment service, not a fulfillment service, but you just letting the consistency like across the entire.
Yeah, and sometimes, and actually, this particular example, the lack of consistency between the customer master record or whatever and the fulfillment service, that's actually a good thing because if the customer makes an order and says, please ship it to me at address XYZ, and then they go and update their address after they've started that order, we actually shouldn't send the order to a different place. Like that's weird.
Okay.
Yeah, I mean, in this particular example. Yeah, but you're right. You're absolutely right that there is. I mean, it's legit to call this an inconsistency, where one part of the system thinks the customer's address is the new address, like the customer service thinks that, and the fulfillment service might, for some period of time, have a stale view of that. Yeah, totally true. Totally true. Cool. Great. So this is the second approach. Does this conceptually make sense? Cool. And then there's a third approach, which we use for kind of slow changing metadata. So at Stitch Fix, we actually, I'm embarrassed to say this, but it's really true. We actually have a table in the shared database that's like, what are the colors? And we have a table in the shared database that represents a size schema. So like the women's sizes are the numeric sizes, like 2, 4, 6, 8. There's small, medium, large, extra large. For men's, there are waist sizes and inseam sizes. Like, you know, those are size schemas in retail speak. And so we have tables that represent that shared metadata in the shared database. If you ask me, and like people did, that's not a place for it. Like I hope that no one ever, I mean, as much as I like services, like I hope no one ever builds a service that returns the US states. Like, hi, what are the US states? Here they are, sir. And someday, you know, maybe Puerto Rico will become a state or something like that, and that'd be cool, but like, you'll have plenty of time. That's not something that's going to change second to second. Anyway, I use the Ruby icon or the gem icon because that's what we use, but it works in any language. So the idea here is just some of these pieces of shared data with metadata that change very, very slowly, that could simply be coupled. Does that make sense? Cool. Okay. That was how I do, or some approaches to doing shared data. Then I want to talk about joins, and then we'll talk about transactions, and then we can all go into things. So again, the problem statement is, in a monolithic database, it's really easy to join tables. Like I simply add another table to the from clause, and I'm good. So, but once I've split the data across microservices, joins are a lot harder. Okay, so again, two approaches. So one is simply do it synchronously. So when I have, let's say in this example, like I want to have an order history page. So I want to show the customer all the orders that we have sent to her. And so I might get some information about the customer record from the customer service. I'll get some order information from the order service about, you know, the orders to that customer, and I'll join them in the application, and then I'm good. And this is basically every web page in the world that doesn't come from just one data source. Does this make sense? Like this, we do this all the time. Cool. So, and again, as with the previous example, there might be reasons why, I mean, it's not great for this example, but maybe I would want to be able to, well, it's not, this is legit. Maybe I want to show the customer's order history even if the order service is down. But that's a legitimate thing that people want. So, we might, so then, the other solution there, the other approach is something that I call materializing the view, and I'm very intentionally using database terminology because I think it's hopefully more evocative than other ways I can say it. But the idea here is, again, I give you a different example where we send boxes, and when people keep things and return things, they give us feedback about each of the 5 items in the box. So there is a many-to-many relationship between items that we have in inventory and feedback that we have received about it. Does that make sense? Like for a particular item, every time we send it out to somebody, it's going to give us, they're going to get some feedback, whether positive or negative. Okay, so let's imagine that we want to create a service that allows me to look at all the feedback for a particular item and that kind of thing. So one could imagine implementing it this way, where there's an item service which produces events when maybe there are new items or when the metadata about an item is changed. And there might be an order feedback service that produces events when we get new instances of feedback from our customers. And then we have this item feedback service that's listening to both those events and like materializing the join or sort of denormalizing this thing in its own storage. Does it conceptually make sense-ish? Okay. If it seems unfamiliar, which would be legitimate, I want to give you some other analogies that can make it seem more familiar. So there are tons of systems that do what I just described, even if it might not seem that they do. So again, I use the term materialized view for a reason. If you use an enterprise class database, i.e. you pay for it, probably they're, Oracle, SQL Server, all these enterprise class databases have this concept of materialized view. Most NoSQL systems, if you use something like Cassandra or React or Voldemort or something like that, most of them force you to do all this denormalization up front. If you use a search engine like Elasticsearch or something like that, probably you are joining together information from different entities in that same system. And also any analytic system that you have, any reporting system that you have is definitely joining together about this stuff. So is now this maybe seeming a little bit more familiar? Cool. All right. Last topic. So how would I deal with transactions? So again, the problem statement is, in a monolithic database, it's really easy for me to do atomic transactions across multiple entities. So I begin a transaction, I maybe insert it to a table, I update another table, and then I commit. And that's ACID, right? Atomic, consistent, isolated, durable. All of that happens all at once or not at all, and has some other nice properties about not being able to observe interim states. But once I have split the data across services, those transactions become really difficult. In fact, I would assert, don't even try. There does exist, a two-phase commit, and there are ways to do distributed transactions. In practice, few people really do them. A good indicator of that is there is no cloud provider that offers distributed transactions on the planet. Not because they couldn't do it, but because when you try to do a distributed transaction across multiple different databases or big stores or whatever, any one of them being down or slow grinds the whole thing to a halt. So it's a real problem of availability, it's a real problem of performance. People at scale don't even bother to do it. Instead, they do something different. So I'm going to talk about something like a workflow idea, or the fancy term is a saga. So what I want, the problem that I have is I would like to update A and B and C kind of all together. Or at least at the end of when I'm done, I like A to be updated, B to be updated, C to be updated. So instead of having that be in one transaction, let's model that transaction as a sort of state machine or workflow of different individual atomic steps where I update A, then B, then C. So here it is a little bit in a diagram. So let's imagine that I first update or insert into A, and I do that atomically in the A service. That's going to produce an event that says, like, okay, customer order created, or something like that, right? And then somebody else downstream could listen, B could be listening to that event, and B could do its associated updates, and then B is going to produce an event, or maybe several, and then C is going to do its work. At least, does it conceptually make sense? So this is not a transaction, right? This is a series workflow of individual atomic operations, and I'll get to more things in a moment. If it fails along the way, the rollback idea is that you simply apply the compensating operations in reverse. So you kind of undo the thing that you did in C, then you undo the thing that you did in B, then you undo the thing that you did in A. Okay, so this is not an ACID transaction. There is no A atomic, there is no C consistent, there is no I isolated. I just hope that it's D durable. But it does allow you to specify a state machine or specify the workflow, and a terminal state in that machine is either it's all the way done at the end or it's not done at the beginning. And you absolutely can, it is not isolated, by which I mean you can observe these interim states. Like you can look and go, oh, I've done A, but I haven't done B yet. So that's different from a transaction in a monolithic database. So if that feels weird, which I'm sure it does, I want to make you feel that it's less weird. So there are tons of common systems that you use every day that do that. So for example, payment processing. So I want Ryan to pay me $20. What I would like to have happen is the $20 gets electronically sucked out of his wallet and immediately ends up in mine in an instant. There's no, well, I like to say there's no payment system on the planet that works like that. And then a guy from Norway came up to me and he said, you know what, actually in Norway it works that way.
Of course.
Everywhere but Norway. Norway's awesome. They have,
They're small.
They're cool. Anyway, so payment processing is like that. And there's a reason why, I mean, like literally yesterday I was at the NASDAQ, and there are some pretty big and beautiful buildings in Times Square. And they're all built on the float between Ryan, the 3 days that it takes to go out of Ryan's pocket and end up in mine. Like, I'm not even kidding. Like, all of New York City is built on that, basically. Expense approvals. So I will be, Cerner was very nice to have me here. They said, please let us know if, send us your lift receipts, and if you buy any food, eat it, send us receipts. So I'm going to give that to them. And that's going to be a workflow, right? So I'm going to give it to them. They're going to submit it to their expense reporting system. It will take it'll get approved, and blah blah blah, and move all the way around up the end state of which hopefully I'll get paid, and there you go. And then any multi-step workflow. Again, as we talked about earlier, I used the example of the development process, right? So very few people have their system set up where when they hit return in your IDE, it's immediately and transactionally and atomically deployed to production. So what I'm trying to give you is like metaphors that you have in your daily life where you actually model important things that you actually want to get done. You model them as a state machine or as a workflow, and it is legitimate for you to observe those interim states. Right? You can say, hey, what's up with my expense report? Oh, it's pending. What's up with my payment? Yeah, it's pending. And you can even say, like, oh, it's made through this step, but it hasn't made through that step. Like, that's a legitimate thing to say. And it accords with lots of people's experience of the real world. Is that making sense? Yeah.
And then you feel that you got undo but then the fact that you can undo every variance that you can, so it seems like there's this widespread possibility for tripping, And I guess you think in the real world that this is the way it works?
Yeah, I mean, I think, if what you're concerned about is that there are lots of different people that can observe these interim states, they all need to be shown. I mean, they all need to be like undone.
Right.
Yeah, you're absolutely right about that. Yeah. Yeah, and that's actually, actually payment processing is another really great example because payment processing can be reversed from the beginning, right? That's like I think it's called reversal, right? You literally can reverse the charge, and that has to trickle all the way through and undo all the stuff. So, I don't apply that it's easy, but I apply that it's doable, and the metaphor makes sense. Like if you're willing to take a step back and take a step back from an ACID transaction where it all happens, there's a legit metaphor here that feels okay once you think about it for a while. Yeah. Right.
We've seen applications that use process managers.
Yeah, that's a beautiful question. So I'll say it back. I never heard that term process manager, but a coordinator. I'm going to use that term. So what you say is, yeah, I've seen transaction coordinators that coordinate across a bunch of different steps in the workflow. Yeah, so it is a saga. As with many event-driven systems, there are two, like I show one way of doing it, and there's another way of doing it with a godlike coordinator. If you're interested in learning more about sagas, there's a wonderful talk by a woman named Katie McCaffrey. She is Katie, C-A-I-T-I-E, C-A-I-T-I-E, Katie McCaffrey. She's simply at Katie on Twitter. She used to work for Twitter. She's a fantastic distributed systems engineer, and she has a wonderful talk that you can find on YouTube about sagas. And she talks about the transaction coordinator approach to it. So, and she's much more, I mean, I'm talking about this for 15 seconds, and she talks about it for an hour. And so there's much more depth and much more rigor that she goes through about how to do it. And she's a great speaker, so I strongly recommend that. So yeah, there are two ways to do these kinds of event coordinating things. The fancy term is orchestration. So if there's a coordinator, that is orchestration, like an orchestra and a conductor. And the other way, this way, is something called choreography. And so choreography is like the choreographer doesn't control it in the moment. The choreographer, like, let's practice this ballet together, and then you guys go do it. Does it make sense what I'm saying? There's a difference between orchestration with a conductor, keeping time, making sure, like, okay, the oboes are around the same time, versus choreography, where the choreographer tells everybody the steps and the moves that they're supposed to do, but then lets them go do it. And so what I'm showing, you correctly note that there's another way to do this, which is really important. Thank you for that. Yeah, totally. It can make that. Which is why I use this when you need to. I mean, it's not, everything's a trade-off, right? So I don't say, give up your database, start doing this as soon as you get back to your desk. It's like, hey, if I can no longer live in a world where there's a monolithic database because it is a single point of failure or a single performance bottleneck, or because that schema is becoming like a velocity bottleneck for my team, I'm trying to show you ways that the eBays, the Amazons, the Googles, the Netflix of the world have tried to solve those same problems. And yeah, again, legit, this is not for, I mean, it's not only for Google, but like, it's not for everybody, right? You should look at it, and I'm trying to be very honest about here are the trade-offs that you're making. And like, it's not all rainbows and unicorns. But what I want, if you only leave with this, I want you to leave with it's possible. Does it make sense? Like, there's a way to do it, and it's legitimate, and it's principled, and you can reason about it. Is it hard? Yeah, it's hard. It's totally hard. Yeah, great. So you can definitely imagine work that crosses multiple services. You can absolutely imagine that. Cross-functional work that crosses multiple services. Going into a new geography, that's a good example, because that's cross-cutting across a lot of stuff, right? So, we're now going to go into France. Well, gosh, everything needs to now speak French and do euros and be metric and all that stuff, and have European calendar stuff, all the stuff. Trust me on this, it is possible, I'll say it this way, in my experience, if you draw the service and team boundaries well, a minority of work crosses team boundaries. A minority of work. Not zero. because we're always going to have big strategic projects that cross a bunch of different services and teams. But I'll say in practice at Stitch Fix, most of the projects are within the bounds of, like maybe 80% of the projects are sort of within the bounds of one team. Oh, testing. Oh, yeah, sorry, I missed the testing part. Yeah, so. Yeah. Yeah. Yeah, I mean, there's a whole bunch to say on testing. I guess I'd say several things. One is, this is not all of the testing, but a lot of the testing you can do in this world is through the service interface directly onto the service, and that is much easier to do in this model because you've done the hard work up front. Like, this is a lot easier to do in this model than it is in the monolithic model, right? So already you're way ahead because the testing you can do for a particular component can be very complete. When you are testing a component in isolation, you do want to make sure you mock out, in some way, you have to mock out all the things that service needs to do its job. And it's not super complicated, but there's a lot of, like, you have to do some thinking about, well, how do I mock out this thing and that thing and the other thing? And that will get you most of the way there. And then when you're trying to test things end to end, yeah, you usually have like toy version of the entire system. Is that helpful at all? Oh, I don't know, like a staging environment, what do you guys call it, QA environment, something like that. I just toy like it's not production. Cool. All right. Let's see. Yeah, please.
Going back to the thing you were talking about, where does the workflow in the choreographer type environment, where does the workflow get written, and are you using messaging for a messaging service to communicate, or what's the communication?
Yeah.
Where's the logic live and where's the data?
No, that's great. Well, the data lives in the services. The logic, if when you say the logic, the steps of the workflow. So again, there's a slight distinction. Yeah, no, sure. Yeah. Well, what's the state of the workflow? Yeah. Again, you can have that orchestration idea. If you use a coordinator, the coordinator owns the state. So like that maintains the current state of the state machine. In this model, and again, everything's a trade-off. In this kind of choreography model, choreograph model, there's really no one place that maintains the state. It's just you start. It's like you just start the snowball and it moves forward, and then if somebody notices there's a failure, they start doing the undo, and then that produces a cascade of events that go the other way. Does that make sense?
Yeah, does the logic live in like the individual pieces?
I guess so. I mean, if you have really super complicated logic, you should do the orchestrated model. I mean, legit, right? If it's a pretty simple workflow, then the logic associated with the workflow is when I am told to do this, I do that, and if that doesn't work, I do this other thing. And like,
are they found each other, or is it floating in separate messages?
They are producing. The typical model I like to have is I'm going to say fire and forget. It's not fire and forget. I produce an event. It is my job to produce an event. I don't know who uses it. Maybe nobody. Well, okay.
What? Is that automated like at 8 o'clock?
That is super cool.
Automated deployment.
Oh, all right. Oh, it's only that one.
High availability.
It's okay. Okay. So I actually have one. I want to let you go, but just because I can't say microservices without a little bit nodding to serverless in this thing. So one of the great things about a model that is like this is that the logic in the A's and B's and C's can be very simple. If it is, and it is very lightweight logic, it's often stateless for some of these things, and it's triggered by an event. So that's exactly a use for functions as a service, so like Lambda or Google Cloud Functions or Azure Functions. Anyway, so it's a thing you could consider. And if you ask yourself, well, as maybe I do, if you ask yourself, well, how do microservices and serverless maybe play together? Like, this is a way. Does it make sense? Like, you can use like serverless or a function as a service is just like a tiny, tiny little microservice that I don't have to figure out how to deploy. So anyway, hope that was helpful to people. Sounds like we're getting kicked out. So. Thanks a lot. I hope I didn't keep you.
Thank you. I'm going to stick around for, I think we got about 20 minutes left in the room. Then we need to start cleaning up and be out here by 8:30 off campus. So hang around, talk about all the awesome things that you learned tonight. Can we get another hand for all of our speakers? I really appreciate Ryan and Dave putting that together. That was awesome. And this has been an awesome talk. And another round of applause for our sponsor, Center, for the food and the spot. Anybody else have any else? All right, I will.
Watch the view, right?
Oh, no.
Cool. Turn it off? Yeah, that's like a talk.
Well, choose what you want to do. I don't know what you want to do with that.
All right. Stop streaming.